Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0102, indicates a low voltage issue in the mass airflow MAF sensor circuit. This can severely impact the engine's performance, as the MAF sensor is crucial for measuring the amount of air entering the engine's intake. Proper functioning of the MAF sensor is vital for optimal fuel injection and emissions control. Located in the intake duct, the MAF sensor sends real-time airflow measurements to the Powertrain Control Module, PCM. The PCM uses this information to adjust fuel delivery for efficient combustion. When the MAF sensor detects air volume less than expected, it triggers the P0102 code. Identifying and resolving this issue requires a systematic approach to diagnose and repair potential wiring faults, connection issues, or the failure of the MAF sensor itself. DTC P0102 pertains specifically to the MAF sensor circuit experiencing low voltage, indicating that the readings from the sensor are not aligning with the expected thresholds. The MAF sensor is responsible for determining the volume of air entering the engine and subsequently informs the PCM to adjust fuel injection accordingly. This sensor is situated in the air intake system, typically downstream of the air filter and upstream of the throttle body. The accurate functioning of the MAF sensor ensures that the vehicle runs efficiently, optimizing fuel consumption and minimizing emissions. When the circuit registers low voltage, it can lead to a lean air-fuel mixture, causing performance issues and increased emissions. If left unchecked, this could result in severe engine malfunctions over time. Several factors can contribute to the occurrence of DTC P0102. First, a malfunctioning MAF sensor itself is a primary suspect. This can arise from wear, contamination, or electrical failures. Second, wiring issues such as frayed or damaged wires can lead to poor conductivity and result in low voltage signals being transmitted to the PCM. Third, there is the possibility of a malfunction within the PCM itself, which would prevent it from processing the MAF sensor's signals correctly. It is imperative to check the integrity of both the sensor and its wiring, as well as to confirm the PCM's proper functioning to address this code. Ensuring a thorough examination of these components can help isolate the root cause effectively. The symptoms that accompany DTC P0102 can significantly affect vehicle operation. The most visible sign is the illumination of the check engine light on the dashboard, alerting the driver to a potential issue. Performance-wise, the engine may exhibit hesitation, stalling, or irregular acceleration, greatly impacting driving experience. Furthermore, the vehicle may experience a noticeable decline in fuel economy due to improper air-fuel mixture ratios. In extreme cases, the engine may enter a limp mode to prevent potential damage, which limits power output and performance to allow for safer operation until the fault is resolved. If you experience any of these symptoms, it is crucial to engage in a diagnostic review without delay. The first step in troubleshooting DTC P0102 requires the technician to turn the vehicle ignition to the on position without starting the engine. This initial step ensures that the vehicle's systems are powered and ready for diagnostic checks. Next, the technician must utilize the Honda Diagnostic System, HDS, to check for any confirmed or pending DTCs. This step is important to understand if other issues are present that might correlate with the MAF sensor problem. Also, it helps in verifying whether P0102 is the only DTC triggered, or if there are additional codes that could lead to further insights regarding the root cause. This diagnostic approach provides a comprehensive overview of potential system failures affecting the performance. In the second troubleshooting step, the technician needs to turn the vehicle to the off or lock mode. Following this, the next critical action is to check the status of fuse number C7, which is a 15-amp fuse located in the under-fuse/relay box. This fuse is vital for the functionality of the MAF sensor circuit. If the fuse appears blown, it will need to be replaced. Additionally, if the fuse continues to blow after replacement, further investigation is warranted for potential short circuits in the wiring associated with the IG1 ACG circuit or the EGR circuit between the PCM and the EGR valve. Detecting electrical faults at this stage is crucial for ensuring that the MAF sensor operates effectively. During the third step, the technician should again turn the vehicle ignition to the on position and allow a brief wait period of around 2 seconds. This pause is crucial as it allows the onboard systems to initialize and prepare for data reporting. After this brief waiting period, the next task involves using the HDS to check specific parameters related to the MAF sensor's performance. Key among these is ensuring the sensor signal is less than 0.1 volts, which indicates an issue. If current conditions match this threshold, it confirms the failure and warrants further diagnostics into the sensor or wiring. If not, it suggests an intermittent issue that may require reviewing connections and terminals. In the fourth step, the technician should switch the vehicle to the off or lock position before proceeding. Following this, the MAF IAT sensor 5P connector should be disconnected to isolate the sensor from the circuit for testing. The next part of this diagnostic involves turning the ignition to the on position again to measure the voltage at the designated test points between the MAF sensor connector and body ground. This measurement is crucial to determine if there is adequate battery voltage present in the IG1 ACG line. If voltage is detected, it suggests that the wiring from the MAF sensor to the under-fuse relay box is intact, guiding the technician to further steps. If no voltage is found, troubleshooting must focus on repairing any breaks or faults in the IG1 ACG circuit. The fifth troubleshooting step involves switching the vehicle to the off or lock mode once again. Here, the technician must measure the resistance between specific test points at the MAF IAT sensor 5P connector. This check is important to ensure that the VGP line is functioning as expected, and ideally, the resistance should fall within the range of 190 to 210 kiloohms. If the measurements confirm this resistance level, it indicates that the circuit is functioning correctly, allowing the technician to proceed further in the diagnostic process. However, if the resistance is outside of this range, it indicates an issue in the VGP line that needs rectifying before moving on to other diagnostics. In the sixth step of troubleshooting DTC P0102, the technician should jump the SCS line using the HDS, which essentially prepares the system to diagnose more effectively. After initiating this step, disconnect the PCM connector A, which contains the necessary wiring for the PCM communication. The next action is to check for continuity between the specified test points while the vehicle remains in the off mode. Ensuring continuity between the MAF sensor/IAT sensor connector and body ground is essential for validating that the VGP wiring is not shorted. If continuity is confirmed, there is likely a short somewhere along the wiring, necessitating repairs in that area. If continuity is absent, it suggests that the VGP wire is functional. The seventh troubleshooting step directs the technician to check for continuity between the specific test points in the disconnected MAF IAT sensor 5P connector and the PCM connector A. The vehicle should remain in the off mode while performing this check. If continuity is detected, this indicates that the VGP line is functioning optimally and not presenting any issues. Under these circumstances, the technician should then check for authorized service information or consider substituting with a known good PCM as the next logical step. Conversely, if the continuity test shows no connection, this implies an open circuit in the VGP wire, thereby necessitating repairs to ensure proper connectivity between the PCM and the MAF IAT sensor. The final step in diagnosing DTC P0102 is to substitute the faulty MAF IAT sensor with a known good component to immediately validate the sensor's functionality. After attaching all connectors securely and ensuring everything is back in place, to the on mode and clear the DTC using the HDS. Following this, start the engine and maintain the engine speed at approximately 2000 RPM without any load. During this operation, a careful check for any confirmed or pending DTCs should be performed. If DTC P0102 does not reappear, then the replacement MAF sensor/IAT sensor is deemed functional. However, if the code reoccurs, it becomes necessary to replace the original MAF sensor/IAT sensor and possibly review the entire circuit for other underlying issues. After completing all troubleshooting and repairs for DTC P0102, the next step is to conduct a thorough test drive of the vehicle. This driving test is essential to ensure that any issues linked with the MAF sensor circuit have been resolved effectively. During the drive, observe the engine behavior, particularly noting any performance inconsistencies. After the test drive, it is crucial to run another diagnostic scan using the HDS to confirm that DTC P0102 does not reappear. This final verification step is integral to confirming the effectiveness of the repairs made. If the DTC remains absent, one can conclude that the repairs were successful and that the vehicle is now operating correctly. To prevent reoccurrence of DTC P0102, regular maintenance on the MAF sensor is essential. Cleaning the sensor periodically can mitigate dirt and grime accumulation that could disrupt its performance. Inspecting the wiring connecting the MAF sensor on a routine basis is also recommended to ensure there are no frayed wires, wear, or short circuits. Adhering to the vehicle's service intervals, as noted in the owner's manual, will support overall vehicle health and performance reliability. Additionally, using only quality air filters minimizes contaminants reaching the MAF sensor, thus prolonging its operational lifespan. Integrating these maintenance measures can help ensure consistent performance and longevity of the MAF sensor and related circuits. In summary, understanding the role of the MAF sensor is crucial for effective vehicle maintenance and performance. DTC P0102 highlights the importance of a systematic approach to diagnose and resolve issues stemming from the MAF sensor circuit. By following the outlined troubleshooting steps methodically, one can locate faults related to wiring, connections, or the sensor itself efficiently. Ultimately, implementing preventive strategies not only assists in avoiding future occurrences of this DTC, but directly contributes to the overall reliability and efficiency of the Honda Pilot. By staying proactive with maintenance, vehicle owners can ensure optimal performance and avoid unnecessary repairs. Please like and subscribe to the channel. See you next time.